battle, we own the skies. Our Navy owns the sea. And we continue to lead the world, pushing that boundary in extraordinary ways. Technology gave us the night. Now, scientists at the Army Research Lab in Adelphi, Maryland, are working on technology that someday will give us the elements, allowing us to operate in the sand, the dust, the wind, whatever nature throws our way, science will give us control over.
Wow, that's a lot of dust.
When it comes to flying in the desert, the #1 enemy may not be shooting back and literally be as small as a grain of sand.
One of the things that are limiting us the way we operate now is the weather. Sometimes the weather defines whether or not we can execute a mission or not. And so as we develop these technologies, it allows us to operate in high sand conditions, in brownout conditions, in high wind conditions where typically we may not be able to operate an air platform. We're building those technologies as part of our portfolio to allow us to operate in any sort of environment, under any weather conditions, at any time of day.
It's a big problem, and that's about the only thing that's clear. As we operate in desert conditions, sand not only kills visibility, but it gets in the air intake of the engines. While there are air filtration systems, they don't catch everything. Particles make it through, causing a rapid deterioration of engine hardware. Using a specialized camera capable of shooting 4,000 frames per second, you can see the superheated sand traveling at incredibly high speeds, slamming into the internal parts of the engine, causing the engine to simply wear out and eventually break down.
Those small particles will actually melt, and then they fly in and they basically attack the stator and the rotors. And those are the heart and the guts of this gas turbine engine.
But understanding how the damage happens inside an engine is only half the problem. How do you prevent the damage in the first place? Well, before we can get to that, we must first consider one simple detail. Engines get hot, very hot. So hot, in fact, that the metal alloys that make up the engine parts would melt if not for ceramics. Engineers are able to keep heat under control using ceramic coating. They're already used in engines because of their heat insulating properties and work very well at keeping things cool. Now these scientists are looking at new ways to use ceramics.
So we're trying to make ceramic coatings that still serve that function as insulators and to protect the metal hardware from the high temperatures, while also being more resilient with the added bonus of basically acting like Teflon in a cooking pan, right, where all this incoming sand would just roll right off.
Getting the sand to simply not stick during flight is the holy grail these scientists are working to achieve. But finding the right ceramic material is a tedious and exacting process. In their lab, scientists and engineers recreate the harsh environment inside a flight engine. They expose the coatings to the different types of conditions within an engine and examine how well the coating was able to withstand the test. Observations are noted, changes are made, and they do it all over again. It's time-consuming work, but the results are encouraging.
My part of the program, we're actually coming up with different chemistries and different coating mechanisms that are showing some promise in being more resistant during various heating and cooling cycles. You're using computer models to kind of cycle through those various test iterations faster without having to go back and make a new coating every time.
So the big question is, how does sand affect readiness?
Currently in the field, in some of these desert environments, engines that are designed to operate for 4,000 hours of service are getting pulled for maintenance because of these sand damages at like 400 to 500 hours. 10 times reduction in service life of this hardware. So it's increasing that longevity, sustainability, readiness, and capability that we really think is going to make the biggest impact.
Another barrier to getting this technology ready for the battlefield is the incredibly rigorous conditions these aircraft must endure. Any technology must be able to withstand the harshest of field conditions. There's much work left to be done, but the stakes are high, as is the scientists' dedication to solving the problem.
In the 90s, we were able to, through night vision, own the night. What we want to do with the next generation of systems is own the environment or own the weather. Be able to operate our systems and our platforms with next generation technologies that will allow us to operate in sand, in wind, in rain, in ice and sleet, in high winds, and not be restricted in our movement by those types of operational environments.
Man versus nature, an age-old problem that may be solved with 21st century technology. It starts here, inside the walls of the Army Research Lab, with a group of dedicated men and women, armed with science, trying to save lives. For many of us, on 9/11, the threat became real. There are some bad people out there who mean to harm us on our own soil. They've used planes, bombs, many different types of weapons, but when it comes to chemical, biological, radiological, or nuclear attacks, known as CBRN attacks, there are specialized military teams ready to meet and deal with that kind of threat. Strategically positioned all over the United States and its territories, they pack some mind-blowing technology that makes them one of the best in detecting, identifying, and dealing with CBRN attacks.
Our primary mission is to support local responders. At the call, basically the governor has to call us in. We support the FDNY, NYPD, and any state and local fire departments or emergency services units.
On this day, one of the units, the 24th Civil Support Team, whose area of responsibility is the New York City area, is conducting a training exercise designed to simulate a real-world scenario involving an unknown chemical agent. Lieutenant Colonel Benjamin Gettner, the team commander, explains how his team tackles the threat.
This morning we got a call about 4 in the morning from the FBI requesting our assistance to identify an unknown laboratory process at a residential building in Brooklyn. What they found was a glassware that was producing a nerve agent. So our mission here today is to make entry into the residential building and identify any hazards related to the process.
The team begins by setting up a decontamination line to remove any contamination they may be exposed to during the containment. They establish a command post, complete with satellite-based communications and a mobile lab truck. Once everything is set up and operational, the soldiers don protective equipment and enter into the hot zone. It's a nerve-wracking and long, tedious process, but being on the front lines of a potentially deadly situation is not something this unit shies away from.
You have to rely on your training and all the training that you've been through, and you just need to trust that you know that everything you're doing is safe and that you're going to go back and rely on the years of training that you've had. And when you do those kind of things, it kind of mitigates some of that fear.
They train using state-of-the-art technology that can rapidly identify biowarfare agents, a threat they see as increasingly real.
So the ALS, or the Analytical Laboratory Suite, first and foremost has a level 3 glove box, which we can take any kind of chemical or biological sample in there, process it, try to identify, try to characterize it, try to identify what it could be. From there, we try to we have a gas chromatograph mass spectrometer, which is short for, or long for GCMS. That is our chemical analyzer. It analyzes any volatile or semi-volatile compounds. It has a database of over 200,000 compounds in it.
And that's just the beginning. Using infrared light, the team is able to identify particles based on its reflection.
We also have an infrared spectrometer hooked up to a microscope, so that as we're looking at white particles underneath the microscope, we can analyze each of those particles with an infrared spectrometer.
Be it nuclear, chemical, or biological, the team is ready for any type of encounter. Their equipment can identify a vast spectrum of toxins.
It does basically an antigen-antibody complex protein identification, if you will, on the surface of particles to see whether or not it is one of the toxins that we're looking for. So we can identify any of our conventional biological warfare agents on that instrument just by analyzing the actual DNA or RNA.
These skilled experts of the civil support teams stand ready 24/7 to combat any possible attack anywhere in the United States.
The threat of a chemical or biological attack is real. That's based on current events going on overseas. The team fills that threat and uses science as a key element to determine the threat and assist our civil authorities in being able to make decisions to help our populace and save lives.
Working side by side with U.S. law enforcement, the civil support teams remain vigilant day and night, armed with science and ready to take the call we all hope they never receive.